Like. Yeah. Subscribe.
Hey y'all, we're going to go ahead and start working on this review for our test. You might notice that this first page doesn't have any questions on it. These are just little clips from your textbook that kind of summarize the concepts that we've gone over. So on the first day we talked about how to solve linear and quadratic equations, right? Here we go. We talked about how to solve linear quadratic equations. And then the second day we looked at how to solve power equations, and we use these exponent properties. This little box here, you're not going to be tested like specifically on these exponent properties, but you do need to know the ones that we talked about during class. And then we also went over how to simplify radicals. So just a little summary of the unit so far. And our problems start on page 2. So we'll just kind of go through these. And if you end up having any questions, or if there's something that you feel like I didn't do a very good a job of explaining, let me know, and I'll try to go back and explain it to you. So let's start with number 1. We're going to use the distributive property, and we're going to distribute the 5 to get 5x plus 30 equals 40. Then we're going to subtract 30 from both sides using that property of equality. That'll leave me with 5x equals 10, and I'll divide both sides by 5 to get 2. So my solution to the first equation is 2. For number 2, I'm going to subtract 4 from both sides, and I get negative 7y equals 21. Divide both sides by negative 7, and I get y equals negative 3. For number 3, I'm going to add 7 to both sides. And so I get m divided by 4 equals 9. I'm going to multiply both sides by 4 here. So I'm going to say times 4 on the left-hand side, times 4 on the right-hand side. And I'm doing that to reduce this 4 divided by 4 as 1. I want to get rid of that and just be left with m equals 36. Number 4, got to combine my like terms. 2x plus x is 3x minus 9. So I'm just going to actually write it like this. I really like having the variables on the left-hand side. It's not required. That's just something I like to do. That way I can rest assured that my final answer will be, x equals something, as opposed to something equals x. Now I know those statements are equivalent, but if we're trying to solve for x, it just flows a little nicer that way. So I'm going to add 9 to both sides and get 3x equals 21. Divide both sides by 3, and get x equals 7. As I'm going through this, I haven't used a calculator yet. I am not shy about when I need a calculator, so if there's something that I need to break up the calculator, I will make a note of that. But for this, so far I haven't used one. Now, not using a calculator, I may make a mistake. So if you notice anything where maybe I'm just working this way too fast, I might make an error here or there, but hopefully not. Number 5, we're going to distribute. I'm actually going to distribute both of these in the same step. So I'm going to start by multiplying 2, and I get 8x minus 10 plus 6x plus 6 times 3 is 18 equals 43. We'll see how this goes, but this might be the first one where I use the calculator. So let's go ahead and combine our like terms here. We've got linear terms of 8x and 6x. And then I have my constants, negative 10 and 18. So I'm going to combine these, and I'm going to combine these. Oh, what the? There we go. Okay, so 8x plus 6x is 14x. And I've got 18 minus 10 is 8. So I need to subtract 8 from both sides. And I get 14x equals, let's see, is that 35? Yeah, so yeah, this is not going to divide evenly, but we can reduce it. So I'm going to say it's equal to 35 over 14, but if I divide both of these by 7, I get 5 halves. So here's number 5. Number 6, you got to be really careful. When you have the number that you're trying to distribute, there's a minus sign in front of it. You make sure that you distribute the negative along with it. So I'm going to distribute a negative 3. Okay, this number right here. So I get 8 minus 3x minus 12 equals negative 7. I'm going to combine my like terms, which in this case is 8 and negative 12. And so I've got negative 3x minus 4 equals negative 7. Add 4 to both sides, and I get negative 3x equals, oh, look at that, negative 3. This one's going to work out nice. So we divide both sides by negative 3, and I get x equals 1. Now, when we look at number 7, you might think to yourself, oh goodness, we've got some fractions here. A little scary, but whenever you see a bunch of fractions in an equation like this, I think the best course of action is to clear out the fractions by multiplying both sides by a number that will change those fractions into whole numbers. So the number you're really looking for here is the least common multiple of all the denominators. So I'm looking at 3, 2, and 6 and thinking, okay, well, what's the smallest number that is a multiple of all of those? And in this case, it would be 6. So I'm going to multiply both sides by 6. 6 times a third, 6 divided by 3 is 2, so 2x. And then 6 times 5 is 30, divided by 2 is 15, so minus 15. 6 times 1 is 6, divided by 6 is 1, so minus 1x. And then 6 times 2 is 12. So notice we've got a much simpler equation here. Really a good idea to get rid of those fractions if possible. I'm going to combine my like terms. 2x minus x is going to be 1x. Switch colors on me. Or I guess I didn't switch colors. Yeah, 1x minus 15 equals 12. I'm going to add 15 to both sides. And I get x equals 27. Number 8 is kind of like what we saw before in number 6, where we had to distribute a negative. But here you don't actually see the number here. And when you don't see that, there's an implied 1. Okay, it's like you're going to distribute a negative 1. So let's go ahead and do that. First, I'm going to distribute the negative 1 to both of these terms. So I get 8 minus 3x minus 4 plus 2x equals 15. Let me scroll this up a little bit. Now I'm going to combine my like terms. So here are my linear terms that will be combined. I also have a couple of constants. So I'm going to put these two together. And I'm going to put these two together. 2x minus 3x is negative x. 8 minus 4 is 4. And so I get this little equation. Next, I'm going to subtract 4 from both sides, and I get negative x equals 11. So I divide both sides by negative 1, and I get x equals negative 11. For number 9, same kind of deal here. Not really doing anything much different. I just took a glimpse at number 10 and thought, oh my goodness, that's a long one. All right. Number 9. Distribute this negative 2. So I've got 5x minus 14x minus 2 equals 14x. Combine my like terms here, which in this case is going to be this 5x minus 14x. 5 minus 14, well, it was, that's going to be negative 9x, right? 14 minus 5 would be 9, so 5 minus 14 would be negative 9. 2 equals 14x, and I need to get this x term over to the other side, don't I? So to take care of that, if you've got variables on both sides, let's go ahead and subtract the 14x on both sides. I'll combine these to get, let's see, that'd be 23x. Now, or negative 23x. I'm going to add 2 to both sides. It looks like I'm running out of room, so I'm going to skip a step here and just go straight to this. So now I need to divide both sides by negative 23. I'm a little skeptical that this is the right answer just because it is a fraction. This would be a good opportunity. Let me clean that up a little bit actually. So our solution here that we got was negative 2 over 23. I'm going to double check in the calculator and see if that is actually correct. All right, so I went in ahead and I tested this solution. Now, the way I did that was in the calculator, I took this number, -2 divided by 23, some long, ugly decimal, and I just substitute it for every instance of x. So in other words, I took this number, and let me erase some of this just to kind of clean it up. I plugged it in here and here. So I did 5 times this, minus 2 times 7 times this number, plus 1. And then I also typed in 14 times that number and saw that the left-hand side did, in fact, equal to the right-hand side. So we got a pretty nasty number here, but that's our solution, y'all. Sometimes you just get a really weird decimal. And it's nothing to be scared of or anything. It's just the way it is. It's just what we get. Number 10. Yeah, leave it as a fraction. Don't bother trying to, estimate the decimal or anything like that. All right, y'all, let's do number 10. Look at this madness. Look at what was I thinking? I think I got carried away with this problem. Let's start with the distribution. I'm going to go ahead and take care of that property first. So we got 20x minus 20 plus 15x minus 15 equals 245. We got a lot of like terms here. So this is where Cami or whatever tool you're using, it's kind of helpful to use different colors, honestly, just so you can underline all the like terms. It's really helpful to me. Now, if you're just using a pencil, what I used to do back in the day was instead of using different colors like this, I would mark a different number of lines here to help me keep track of it, just visually. So I would do something like this, say, oh, those are my linear terms, and then my constants just have one line, just as a way to help me kind of group them together visually. With different colors, not really necessary, but most of y'all are probably just using a pen or something. Okay, so let's go ahead and combine all of these, and then we'll also combine these two. So 20 plus 15, okay, we got a lot going on here. 20 plus 20 is 40. 15 plus 15 is 30. So 40 plus 30 is 70, so we get 70x. Forgot to switch back here. So we get 70x. And then we got negative 20, negative 15 is going to be negative 35. So now we want to add 35 to both sides. And I get 70x equals 7, that'd be 80. Okay, so 280, divide both sides by 70, 28 divided by 7 is 4. Right, these would cancel out, so 28 divided by 7 is 4. So far, y'all, the only time I used a calculator was to check this answer. And so I didn't really need it to solve it out. And y'all know my arithmetic is not the greatest. So the addition, subtraction, multiplication stuff, it should not be too difficult. So try to get away with not using a calculator. 5x, so this is, okay, let's look at number 11. If 5x plus 6 equals equals 10, wow. What is the value of 10x plus 3? Well, in order to answer this second part of the question, we need to know what x is so that we can go back and plug it in there. So whatever we get, let's say we got 2 for x, we plug it in here and get 23. So whatever we get from this equation, we'll go back and plug it in there. So we're going to subtract 6 from both sides. We get 5x equals 4. Divide both sides by 5 and get x equals 4/5. So this is a number that we're going to plug in right here. So if x is 4/5, then we're going to say that, okay, so 10x plus 3 equals 10 times 4/5 plus 3. 10 times 4 is 40, divided by 5 is going to be 8. So 8 plus 3 is 11. All right, moving on. Number 12, our good friend Stan attempted to solve for n in the following equation. And it's just asking, really, it's where's the mistake, or is there a mistake? So let's just kind of follow Stan's work here. we are going to distribute the 8, and that would be 8n plus, oh, right away. Come on, Stan. Stan. 8 times 20 is not 20. So the first mistake's in step 1. Gotta love it when the mistake happens right away. Just makes it makes your life a little bit easier. I don't even have to look at the rest of it. Now, assuming, let's see, I'm just curious. Let's see, minus 20, and the rest of it looks good. That's the only mistake there. Well, this is obviously not the right answer because you messed it up. Okay, number 13. Find the value of y if the perimeter is 63 feet. Okay, so perimeter means we're going to add up the lengths of all the sides. So we've got y plus 1 plus y minus 1 plus 2y plus 1 plus 3y plus 1. And I'm getting those from these side lengths over here. It says the perimeter is 63, so we're going to solve for y here. I'm going to group my linear terms, all these y terms. I'm also going to group my constants. Keep clicking on stuff over here. Okay, so here are my 4 linear terms. Y plus y is 2y, plus an extra 2y is 4y, plus 3y is going to be 7y. And then we got 1 minus 1 is 0, plus 1 is 2. So plus 2 equals 63. I'm going to subtract 2 from both sides. And I'm left with 7y equals 61. Oh, no. This looks pretty bad, but I think it's right. I mean, it wasn't any difficult arithmetic here unless I just totally bungled something. Let's test it. I'm going to test it in the calculator and see if it checks out. So I'm going to plug in. I'm going to do 61 divided by 7. I'm going to store that so I don't have to keep typing it over again. And I'm going to do that number plus 1 plus that number minus 1 plus 2 times that number plus 1 plus 3 times that number plus 1. I'm hoping it's 63, and it is. Okay, so we're good. We're safe. Phew. All right. Yeah, these kind of problems where we get the fractions always makes me wonder, was that really a typo? Was there something that, was this supposed to be a whole number or not? Oh well, moving on. Number 14, determine the value of x for the triangle. Hint, the sum of the interior angles of a triangle is 180 degrees. Hopefully you remember that from geometry. I wasn't going to put this hint there, but I thought, you know what, I'm going to cut you all some slack, especially this early in the year, and just go ahead and tell you that. So we're going to set it up and solve it just like the last one. 7x plus 3 times x minus 5 plus 30 should equal 180. So we're going to group our terms. Oh, no, before we group, we need to distribute. How about that? So we got 7x plus 3x minus 15 plus 30. Well, look at how these are grouped. That'll be nice. So like when we combine them, our like terms, they're right next to each other. It makes life a little easier. 10x minus 15 equals 180. 15.
Oops, I made a little mistake here. Negative 15 plus 30 is actually going to be 10x plus 15, which will affect the rest of the answer. So let's go ahead and finish this up the right way. We've got minus 15 on both sides. 180 minus 15 is going to be 165. So we're going to have 10x, see if I can squeeze this in here, equals 165. And then when you divide both sides by 10, you're going to get 16.5. So that should be the correct answer here. There we go. All right, so that fixes that one. There's a couple other errors here, but I'll try to catch those as well.
Number 15 and 16 are open-ended questions. They say write an equation that has no solution, and 16 is write one that has infinitely many solutions. So you could go as simple for this first one, no solution. What you're looking for is an equation where all the variables cancel out and you end up with a false statement. So like, let's say I have x equals x plus 1. In this case, I could subtract x from both sides and get 0 equals 1. That would be a false statement, so it would have no solution. So here's one option. You know, you might have something like, here's some examples, okay? You might have like 2x plus x equals 3x plus 5. You can see how the x's will cancel out. You get 0 equals 5. So maybe, how should I write this? I'll say answers may vary. But any of these, either of these will work, or I'd really recommend that you, try your own. Set up an equation and then solve it and see if you get no solution. To get infinitely many solutions, we need the exact same thing on both sides. So we can have something as simple as x equals x, or we could say 2x plus 2 equals 2x plus 2. Or if you really want to get crazy, you could do something like 2 times x plus 5 equals 2x plus 5 plus 5, or something like that. Okay, where if you distribute and combine like terms, you'll see you have the same thing on both sides. So, so no solution means you get a false statement. Infinitely many solutions where you have the exact same thing on both sides, so you end up with a true statement. All right, let's move right along to number 17. Where's number 17? Hello. Let's go ahead and refresh this page. See if it comes back up. Sometimes Cami doesn't like to load the whole page. I'm not sure why that is. And now we're looking like, I'm going to go ahead and pause the video here until this thing loads up. All right, there we go. I know y'all have had some issues with Schoology loading, or just documents period loading on the school Wi-Fi. Anyway, let's move on to number 17. Oh, nope. Okay. There we go. So number 17, and really for the next few problems, we're going to be working with factoring. So what you want to do is be able to identify whether or not you want to be factoring out a GCF first, or if you just want to go straight into the factoring. So really the difference between the equations where you want to factor out a GCF first or not, you want to be looking at the constant. If there is no constant, so like here's a constant, for instance. Here's a constant. The constant is the number that does not have an x on it. If you've got a constant, then you're going to factor it, kind of the old-fashioned way. But if you do not have a constant, you can use the GCF to make life a little easier. So like if I look at number 17, I notice that I can factor out an x as my GCF, my greatest common factor. So I'm going to factor out an x. That leaves me with x minus 5 as my other factor. Once you have a product that equals 0, we can utilize the zero product property to say that either x is 0 or x minus 5 is 0, and solve those individually. Now this one over here is already solved, so we don't really need to do anything with that. I'm just going to rewrite it. And then for this other one, we're going to add 5 to both sides, so we get x equals 5. Number 18, we'll solve very similarly. We're going to factor out an x and have x plus 11 as my other factor. Whoa, what happened there? I think I just clicked something. Okay, that looks a little better. We're going to, what was I saying? We'll factor out the x. We have x plus 11 as the other factor. So we end up with two solutions, x equals 0 or x equals negative 11. Kind of skip this step over here. In Algebra 1, you really want to make sure to show every little step. In precalculus, we can make some assumptions here. I think it's safe to just kind of go there. Just be careful. Number 19, now this we do have a constant, so we're going to have to factor it like we did before. Not like 17 and 18, but like we did a couple days ago when we went over this. So we want to factor it. So we know we're going to have two binomials whose product is 0, and the leading coefficient is 1. So we just need to figure out two numbers whose product is 6 and whose sum is 5. So those can be 2 and 3. So we get x plus 2 and x plus 3. Let me clean that up a little bit. X plus 2 and x plus 3. I know my handwriting is hard enough to read as it is, so try to do my best to make this clear. So here we're we're going to use the zero product property. You know, either x minus 2 is 0 or x minus 3 is 0. I'm sorry, x plus 2 is 0 or x plus 3 is 0. My bad. So our two solutions are going to be x equals negative 2 or x equals negative 3. For number 20, we're starting to deal with negatives, which can make it a tad bit harder to come up with those two numbers, but not impossible. So here we're looking for two numbers whose product is negative 12 and whose sum is 4. So let's see, that would be 6 and negative 2. So x plus 6, x minus 2. And so our two solutions would be negative 6 or 2. Number 21, the two numbers that multiply to give me negative 9 and add up to negative 8 would be negative 9 and 1. So my two solutions here would be x equals 9, x equals negative 1. On number 22, it looks like we want to factor out an x, but be careful, this isn't 0 yet. The very first thing you should do in all these quadratics is rewrite the equation so that it equals 0. So in this case, we would subtract 10 from both sides to make it equal 0. And now we can do the factoring part, meaning we want to find two numbers whose product is negative 10 and whose sum is negative 3. So that would be negative 5 and positive 2. So my two solutions are going to be 5. So x is 5 or x is negative 2. Not too bad so far. We haven't hit any hard ones yet, I don't think. Number 23, kind of like number 22, in that we need to set it equal to 0. We want to get rid of this thing. So we got x squared plus 10x plus 16 equals 0. And the two numbers that multiply to give me 16 add up to 10 will be 8 and 2. My solutions, therefore, would be x equals negative 8 or x equals 2.
Looks like this is another case of me going too fast. When you have x plus 2 equals 0 and subtract 2 from both sides, just to be x equals negative 2. So this solution's right. All this works fine. But yeah, this should be negative 2.
Number 24, same deal. I mean, all these are kind of working out the same way, aren't you? We're going to first set it equal to 0. Then we want to come up with two numbers whose product is negative 15 and whose sum is 2. So let's see, I think that would be 5 and negative 3. It doesn't really matter the order here. I mean, if you were wondering, like, well, which one do I put first? It makes no difference at all. It's either one thing or the other. The order is not important. Multiplication has a property called commutativity, which states that the order doesn't matter. So in other words, like 2 times 3 is equal to 3 times 2. X plus 5 times x minus 3 is equivalent to x minus 3 times x plus 5, and so on. Number 25, two numbers that multiply to 49 but add up to 14. This one's pretty easy. This one's going to be 7 and 7. And there are some cases where we get a repeated factor here. Now, there is some significance to that. I think we've talked about that before. We don't need to worry about it quite yet. Right? We can say x is negative 7 or x is negative 7. We don't need to write it twice. We could just say x is negative 7. There's only one solution there. Now let's finish off this whole thing about quadratics with writing some quadratic functions, some equations rather. Write a quadratic function. Really this should say write a quadratic equation. So we're not going to have two variables. Just a little technicality there. Probably most of y'all probably would read right past that and not even think about it. But stuff like that catches my eye. Okay, so if x equals 2 is a solution, that means we have a factor x minus 2. And if if negative 1 is a solution, and x plus 1 is going to be one of our factors. Basically what we're doing here is we're working backwards. So we're starting with the solution and trying to get back up here. Then we want to multiply these together. So x times x is x squared. Then we've got plus x minus 2x minus 2 equals 0. So we get x squared minus x minus 2. So here's the equation. It's quadratic. It's a quadratic equation in standard form that would have the given solutions. For number 27, we've got our first factor is x minus 4, and our second factor would just be x. So this is kind of like one of these factoring problems like we had in the beginning, where you factor out a GCF, right? And we saw in both of those you got x equals 0. So if you ever have x equals 0 as a root, you know that x is just going to be one of your factors. So multiply that out, and I get x squared minus 4x equals 0. Eesh. Getting a little sloppy here with the handwriting after doing all these problems. Now, if there's only one solution, but it's got to be quadratic, then that factor has to happen twice. If it was cubic and had one solution, you'd have 3 of these. If it was linear, you just have one of them. But we do have 2, so we get x squared minus x plus 1 equals 0. So my equation in standard form will be x squared minus 2x plus 1. That takes care of the first day. Let's take a look at the second day stuff, I think. Oh, wait, no, we're still dealing with quadratics a little bit, but we will get into how to solve these using exponents. So let's go ahead and start by adding 16 to both sides, and that means x squared equals 16. Now, when it's squared, you're probably used to just square rooting both sides, and you are welcome to do that. You could also raise both sides by the 1/2 power. It is essentially the same thing. In other words, you can either square root both sides like that, or you can do something which is equivalent, which is to raise both sides to the 1/2 power. Either way is fine, how you want to write that. So we get x equals the square root of 16, which is 4, but because we are taking the square root, or a 4th root, or a 6th root, or some even root, we do need to include the plus or minus. Whoa, 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 there we go. For number 30, we need to add 55 to both sides. Am I going to need the calculator here? Let's hope not. 26 plus 55 would be 7 is 81. Oh, look at that. So it works out pretty easily. We're going to raise both sides to the 1/2 power. And we will get x equals plus or minus 9. 9 is the square root of 81. Number 31, we've got a binomial which is being squared. Don't worry about trying to square that out and moving the 9 over and doing all that factoring stuff. You don't have to do that. Instead, just raise both sides to the 1/2 power, or take the square root of both sides. And we'll get x plus 3 equals plus or minus 3. Okay, we're still going to get 2 solutions here, but when we subtract 3, which let's go ahead and do that, we get negative 3 plus or minus 3. We subtract 3 from both sides. Let me show that step just to make it real clear. And so we want to, if you want to leave it like that, that's okay. But if you actually want to figure out what your solutions are, you would say x equals negative 3 plus 3 would be 0, and then negative 3 minus 3 would be negative 6. So these would be our solutions here. Doesn't want to write for me. What happened? Hello? All right, there we go. I'm not sure what happened there. So negative 6 minus 3 would be negative 6. What did I say? Negative 3 minus 3 would be 6. Number 32. I'm going to add 371 to both sides. Oh, goodness. Why do I do this to myself? Well, hold on. This will actually work out nicely, because 9 plus 1 is 10. Carry the 1, 2, and 9 is 7. Okay, so, yeah, this is just going to be straight up 400, right? Divide both sides by 4, and I get x squared equals 100. Hopefully you kind of see where this is going. We're going to end up with x equals plus or minus 10. For number 33, we'll start by taking the square root of both sides, or raising both sides by the 1/2 power. So I get x plus 3 equals plus or minus the square root of 9, which is 3. Is this the same problem? It is the same problem. Oops. Look at that. I don't know why I gave it to you twice. We don't need to solve it again. Okay, I'll just say C31. Yeah, I guess Look at that. It's not even the same font. I don't know. I guess I just randomly found two questions. Yeah, I don't know what happened. I'm not sure what happened there. Number 34. We're going to divide both sides by 4. So we'll get x plus 1/2 squared equals 25 over 4. Now don't be scared about this fraction, because when we take the square root of both sides or raise both sides to the power of 1/2, we can do that to both the numerator and the denominator individually. And if you look closely, you'll notice both of those are perfect squares. So when I raise both sides to the 1/2 power, I'm going to apply that 1/2 power to both the numerator and the denominator. So we get x plus 1/2 equals plus or minus 5 over 2. And then I'm going to subtract 1/2. So I get x equals negative 1/2 plus or minus 5/2, and we'll have our two solutions. X equals, let's see, negative 1/2 plus 5/2 would be 4/2. 4/2 would be 2. So actually, let me back up. 4/2 is 2. And then negative 1/2 minus 5/2 would be negative 6/2, which would be negative 3. All right, some good solving there. Let's move on to some square roots. We want to simplify these. So here we're trying to find the largest perfect square factor of the number that's underneath the radical. We want to divide that out. So let's go ahead and do that. Let's see, 48, 4 for sure. 16 is a maybe. 16 times 3? Let me think about that. I think that is going to work. So I'm going to rewrite this as square root of 16 times the square root of 3. And so I get 4 root 3. 20 is going to be 4 times 5. So square root of 4 times square root of 5 is going to be 2 root 5. Remember, we're looking for those perfect square factors. So like 4, let's see, so 2 squared is 4, 3 squared is 9, 16, 25. These are the kinds of numbers we're looking to factor out. Square root of 125, well, 25, just wrote it, right? So we can rewrite this as, let's see, 25 times 5. Yeah. Just think, quarters, right? You get 5 quarters, that's $1.25. So we get 5 root 5. And then finally, root 72 is going to be 9 times, oh wait, actually, since 8 has a factor of 4, we can go bigger than 9. That's kind of your clue. Hey, wait a minute, you still have a little bit more to go. So actually, I think 36 is going to be what we want. 36 times 2, yep. Ah! What happened there? You good? I think so. So we get 6 root 2. Okay. Now we might have to do a little bit of this on the equations down below. Well, let's see what happens. So let's look at number 39. And we want to solve this. We're going to subtract 2 from either side and get x squared equals 128. We are going to take the square root or raise both sides to 1/2 power. Get plus or minus root 128. And so did we do 128 before? No, we did 125. So 128, though, we can write as, let's see, it's definitely divisible by 4. It's divisible by 16. I guess I'm curious, is 64 going to work? Yeah, 64 times 2 should work. So this would be x equals plus or minus root 64 times root 2. Root 64 is 8. So we get plus or minus 8 root 2. That would be the simplest radical form. Number 40, we're going to subtract 16 from both sides and then divide by 2. So after we subtract 16, we get 2x squared equals negative 12. Divide both sides by 2. And then, wait a minute, we have a little bit of a problem here. Squaring something will make it positive if it's a real number. So there's not going to be a real number I can square to make it negative. So we're going to say no real solution here. There is technically a solution, but it's not real. Okay? It will be complex, meaning it'll have an I involved in it, an imaginary number. We're not really going to get into that quite yet this year, so it's okay to just go ahead and say there's no real solution. For number 41, we're going to add 5 to both sides. So we get x minus 16 squared equals 20, and we'll take the square root of both sides, or in other words, raise both sides to the 1/2 power, and I get x minus 16 equals plus or minus the square root of 20. Pretty sure I can reduce that. I need to add 16. This is going to be a pretty nasty number here. So, okay, let's see here. Root 4 times root 5 means 2 root 5. And that's it. You don't have to go any further. Okay, you can't combine these because this number is irrational. So you're just going to leave it as is. All right, so we're getting to a little bit more complicated. We got some power equations here we're going to solve. What we need to do here, we have a power equation, is we need to raise both sides to a power, and that power will be the reciprocal of the current power. So in other words, like we're doing x to the 5th, we want to get rid of that, so we need to raise both sides. Why is this not writing for me? To the 1/5 power. Okay, so the 5th root of negative 32, what number times itself? 5 times is negative 32, that'd be negative 2. Now, if this was an even number, like let's say it was like 1/4, we would have to do the plus or minus. But since it's odd, we do not. Number 43, we want to raise both sides to the 5th power. We do 2 to the 5th, which you should know if you did the last problem is going to be 32. Number 44, now you might want to rewrite this. Okay, this is really like x to the 1/3 power equals negative 3. So just a little tip here. So what we need to do is we need to raise both sides to the power 3. We get x equals negative 27. 3 times 3, negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. Number 45, we're going to raise both sides to the 3/2 power so that we can cancel out that exponent. And that gives me x equals, now when you're trying to evaluate this without a calculator, I like to do the root first. It's just a little bit easier to make your number smaller before you make it bigger. So the square root of 16 is 4. And then so 4 cubed would be 4 times 4 times 4 would be 64. Right, let's see, 4 times 4 is 16. Yeah, I think that checks out.
This is something that I catch a little bit later in the video, I think like maybe 2 problems later. But at this step where I take the square root of both sides, I neglected to include a plus or minus here, which since we're cubing it, it's still going to remain plus or minus. So this should be plus or minus 64, not just 64.
Number 46, we're going to subtract 10 from both sides. And we're going to raise both sides to the 2/3 power. So we get x equals, now this number in the denominator, oh, wait a minute, hold the phone. Okay, well, let's finish this first. This number is even, so, I'm sorry, 3 is not even. What am I talking about? 3 is an odd number, so we don't need the plus or minus. Okay, so let's take care of this though. The cube root of 27 is 3. 3 squared is 9. Okay, so x equals 9. I need to back it up because I forgot to mention something. I don't think I missed it anywhere else. Number 45. Since the denominator of this power is even, I forgot something. When this is even, then we need the plus or minus. So it should be plus or minus 64. Number 47, let's rewrite this. I'm going to rewrite this as x plus 1 to the 2/3 power. I'm going to add 5 to both sides. So that's going to give me 4. And so now what I want to do is raise both sides of the equation to the power of 3/2. That gives me x plus 1. Now do I need the plus or minus? Well, I examine this denominator here. It's 2, which is even, so I do need the plus or minus here. Wait, it's not going to be 4. Let's see what it's going to be. So, like I did with number 45 and 46, we are going to take the root first and then do the power. It's always going to be power over root. What the? All right, come on now. So I just wanted to write power over root. Okay, so do the root first. The square root of 4 is 2, and 2 cubed is 8. So now we're going to subtract 1 from both sides, and I get negative 1 plus or minus 8. So x equals negative 1 plus 8 is 7, and negative 1 minus 8 is negative 9. All right. We're making some good progress here. 50 questions. Oh, goodness. We got to be close to being done here. Number 48. Oh, we're just rewriting these using rational exponents. There's not really much to say here. Okay, so basically, if you've got something in this form, this is equivalent to saying x to the power of a over n. Remember, that power is going to, or that exponent is going to be power over root. So for 48, we're just going to rewrite this as 17 to the 2/5 power. 49, we'll say 23 to the, now 6 over 3 is reducible. If you leave it like that, it's okay, but a better answer would be 23 squared. Number 15, we've got negative 79. Make sure to put that in parentheses because it's negative, and we want the negative to stay with the 79. To the power of 8 over 11. That's it. Not much to say about these problems. Now that looks like 111. Let's try. That is a pretty ugly 8 as well. Let's just try to fix that. 8 over 11. Last section here, we're rationalizing a bunch of denominators. So to do that, we want to multiply by the root that we find in the denominator on both the numerator and the denominator and simplify. So for 51, we're going to multiply this by root 5 over root 5. And so that will give me root 10 over 5. And we actually can reduce this because root 10, oh wait, can we? No, because 4 and, yeah, that's going to be it. Number 52, we're going to multiply by root 3 over root 3. So I get root 3 over 3, and oh, that's it as well. Once you get the hang of this whole rationalizing thing, it becomes pretty easy, especially when there's nothing to simplify underneath the radical. For number 53, we've got, well, square root of 4 is just 2. Okay, so that's pretty straightforward. Let's go ahead and just multiply both by, well, should we? Yeah, let's just go ahead and do it. Let's see what happens. Root 8 by root 8. Okay, so this is, we already know this is going to be 2. Right, but root 8, let's go ahead and just multiply it out. So we got 4 times 8 is 32, so we got root 32 over 8. And then 32 can be simplified. That's 16 times 2. So root 16 times root 2 over 8, and root 16 is 4. So we get 4 root 2 over 8, which we can even simplify further because 4 over 8 is 1/2. So we get root 2 over 2. Number 54, we're going to multiply by root 8 on the numerator and the denominator. So 7 times 8 is going to be 56. So we get root 56 over root 8. I'm sorry, just over 8. Now 56, let's see here. I think 4, yeah, it's divisible by 4. If I do 4, that'd be 1, 16. Yeah, so it'd be 4 times 14. So we would have root 4 times root 14 over 8. Square root of 4 is 2. So we get 2 root 14 over 8. And this 2 over 8 reduces to 1/4. So we get root 14 over 4. I can fit this little box in here, barely fit it on the page. Number 55, I'm going to multiply by root 3 times root 3. So 4 times root 3 is just going to be 4 root 3, and root 3 times root 3 is 3. Nothing to reduce there. Number 56, we'll multiply by root 2 over root 2. So that gives me root 2 over 2, and nothing to reduce there either. 57, I'll multiply by root 7 over root 7. Now, square root of 9 is 3, so I'm just going to leave it like that. 3 root 7 over 7. And that's it for that one. Let's get rid of that little stray mark there. And then last problem. You guys have been patient, sticking with me this whole video. We're going to multiply by root 3 over root 3. So we got 150, root 150 over 3. Now we need to reduce that. So we've got a factor of 25 here, might be the biggest one. Let's see, it'd be 25 times 6. So yeah, so root 25 times root 6 over 3, and root 25 is 5. For 20 and 21, we're trying to write the equation in slope-intercept form, but we're only given 2 points. So the steps we want to take to get this into slope-intercept form is, first, we want to find the slope. So that'll be step 1. The second step is we're going to write the equation in point-slope form, and we can use either point as our x1, y1. And then the last thing is going to be to solve for y, so that we can get it into that slope-intercept form. So for number 20, first we find the slope. My change in y is going to be this number that I need to add to get from 2 to 4. So this is like my delta y here. This is my change in y. Okay, so that would be 2. My change in x is also 2 to get from 1 to 3. So my slope is going to be 2 over 2, which is 1. And I'm going to use that to plug that into point slope form. Okay, so I'm on step 2 now. Point slope form is written right here, okay? Y minus y1 equals m times x minus x1, where m is the slope, and then this x1, y1 is just any point on the line. So if you're given 2 different points, you can use either one to plug this in. I chose to use 1, 2, but it doesn't really matter. You could do either one. Once you plug in 1, 2, you can distribute and then add that constant over, and you'll end up with your equation. For number 21, same thing. My delta y here, it was 4, my change in y. My change in x was 2, so 4 divided by 2 is 2. That's my m value. And the point that I chose to use here was -6, -5, although I could have used -9, -8. Doesn't really matter. Or, I'm sorry, -8, -9. Once you simplify that equation and solve for y, you get 2x plus 7. And so that would be your equation in slope-intercept form. For number 22 and 23, we're solving a system of linear equations. So this is going to take a little bit more explanation, I think. But basically what you want to do here is you want to make sure that one of your equations is solved for a variable, in this case y is isolated, and take that expression and substitute it into the other equation. So this would be -2x minus 3 times, instead of writing y, we'll write that 6x minus 11 equals -7. Solve that equation for x, and that's what's kind of going on here. I'm distributing the -3, okay? So I'm distributing this to get -18 plus 33. Then I'm combining my like terms to get -20x plus 33. And then subtracting 33, dividing by -20 to get x equals 2. But recall that what we're trying to find here is a point, an xy coordinate where these two lines cross. In other words, like a pair of x and y, that if we plug it into either one of these two equations, they'll both be true. And so it's not enough just to get the x, you do need to get the y as well. And to get that, we can plug in the 2 into either one of these two equations. But I went ahead and plugged it into the first one. just because the y is already isolated. And that way I don't have to solve anything. I just need to knock out the arithmetic here. So I have 6 times x, which is 2, minus 11, which ended up being 1. So my solution was 2, 1. For number 23, I just follow those exact same steps with one added little catch here, and that is neither one of the original two equations have a variable that's isolated. So I decided to solve for y in the first equation. Okay, I'm basically isolating this y, and I do that by subtracting 2x from both sides to get this negative 2x plus 20. So now I've got an expression that I can plug into the other equation. This is kind of like what we did more recently, which is compose two functions. I mean, essentially, that is exactly what we're doing here. So I plugged in negative 2x plus 20 here to get this equation. 6x minus 5 times negative 2x plus 20 equals 12. Then I use the distributive property and multiplied this negative 5 into the parentheses to get 6x plus 10x minus 100 equals 12. Then I combine my like terms here. 6x plus 10x equals 16x. Added 100 to both sides, divided by 16 and got 7. And then I took that 7, and you don't actually have to plug it into like the original equations like these two. If you manipulated one so that you could isolate one of the variables, you can also plug it into here, which is what I did. So I had negative 2 times 7 plus 20, which gave me 6. So my solution was 7, 6. We're still working with linear functions here. And here we're going to find the x and y intercepts of the graph and then graph the linear equation. So we're just taking a slightly different strategy here. We're not going to find the slope. We're just going to find 2 points and then play connect the dots. To find the x-intercept, we're going to set the y coordinate equal to 0 and then solve for x. So if I do that, I'm just left with 4x equals 8 because 8 times 0 would just be 0. And so dividing both sides by 4 gives me x equals 2. So that tells me my x-intercept is going to be at 2, 0. To find the y-intercept, I'll do a very similar I'll do something very similar here, and that is to plug in 0 for x and then solve for y. So if I plug in 0 for x here, that's going to leave me with 8y equals 8. And dividing both sides by 8 is going to give me y equals 1. So my y-intercept is at 0, 1. So now I can plot both of these points. 2, 0 is going to be right here. 0, 1 is going to be right here, and I can go ahead and draw the graph. Notice how I did not need to find the slope here. That is not going to be necessary. All right, there we go. For number 11, I'm going to do the same thing. I'm going to plug in 0 for y to find the x-intercept. Oh, those arrows are terrible. We're going to plug in the 0 for y to get the x-intercept. And so we get 21x equals 28. Lovely. So we're going to divide both sides by 21 to get 28 over 21. Pretty sure that can be reduced. I think well, what are they both divisible by? I think you know what? They're both divisible by 7. So, yeah, 28 over 21 is going to reduce to 4/3. So my x-intercept here is going to be 4/3, 0. Oh.
And that's it for the review. Thanks for watching, and have a great day.